So I'm introducing. So this is a very special talk we have. This is not just one person, but it is. I think there's 8 people in this talk, and they are. It's like the entire ESPN analytics group. And a question you might have is why am I chairing another session this afternoon? I chaired one this morning, and the answer is that Mike Lopez was supposed to chair the session in the morning, but he called me last night and he told me he explained to me that he was a big deal and he doesn't do this stuff anymore. And then he swore a lot and he hung up the phone. So I ended up replacing him. That's not true, but it's a funny story. So here's the people who are giving this talk. We have Lauren Poe. Lauren Poe is an associate sports analytics developer and has worked at ESPN for 7 years. She works with several groups to integrate and store data, build databases, and create tools used for storytelling. So you guys can I guess you can wave as I. There's Lauren waving. We have Hank Garglio. That's close enough. Hank Garglio is a sports analytics developer and has been with ESPN for 13 years. He's worked on a variety of projects, including total QBR and various power indices. And Hank is waving somewhere. There is Hank. Mitchell Wesson has been with ESPN for a year as a sports analytics associate and previously worked in analytics at Lowe's and Wells Fargo. Andre Snellings has been a senior writer at ESPN for 3 years, primarily focused on fantasy sports, the NBA, analytics, and sports gambling. Matt Morris is somewhere. I don't see. There's Matt Morris. He's now associate director on the sports analytics team. He has been at ESPN for 10 years in a variety of roles, including jobs in technology and management. Neil Johnson has been at ESPN on the ESPN Sports Analytics team for over 4 years as a sports analytics developer and has published work in both basketball and in machine learning. Michael Protos is an associate director at the Stats and Information Group's content team and has worked at ESPN for 8 years with a focus on analytics and sports betting information. And finally, Brian McDonald has been with ESPN for a year as director of sports analytics and was previously with the Florida Panthers and was a professor at the University of Miami and West Point. He is also the reference level in my hair scale, which runs from Brian McDonald to Ron Yurko. I'm so funny. All right, so so that's more than 8 people. That's it's 8 people. All right, so without further ado, I'm going to hand it over to Brian, and he's going to explain everything that happens at ESPN. All right, I'll mute myself.
I feel like I should now say that Greg is my reference for beards, from Brian McDonald to Greg Matthews. But anyway, yeah, thanks, Greg, for that introduction. And thanks to the organizers, especially June, for inviting our team to talk here today. So we're going to be talking about redesigning our NBA BPI metric. And before we start, let's just give a little bit of an introduction and talk about why ESPN even has a sports analytics team in the first place. And so the team was formed about 10 years ago by my boss, Jeff Bennett. And one of the big reasons the team exists is because professional teams started using analytics to make decisions, whether they be coaching decisions or player personnel decisions. And so if ESPN was going to intelligently talk about those decisions and teams were using analytics, then ESPN should be able to talk about those from an analytics perspective. And so today we'll be talking about NBA BPI, our basketball power index, which is one of the metrics that helps us do that. And we're going to be kind of trying to focus at least a little bit on each step of the data science process. And not just the sort of the model building aspect, but we're going to start with what is the motivation behind doing this redesign? Why did we redesign it? And so and just about formulating the goal of the project. And with that, I'll turn it over to Michael Protos.
Thanks, Brian, and hello, everyone. One of the charges I have working in our content division and stats information group is working with our team of researchers to help producers and editors across all the different platforms at ESPN tell those stories like Brian was talking about there. The previous version of BPI was one of the many great tools that this analytics team produces that helps tell those smart stories. Translating that for producers and talent and editors takes a little bit of effort, but some of the things that we are looking for is making sure we can be as clear as possible, so that whatever we present to them then gets translated to the audience clearly as well. So the previous version of BPI, when we go about explaining it, usually relies on a few different things: Vegas predictions before the season, game outcomes, rest, and travel. Those factors allow for a very robust model, but there are some limitations. In particular, one of the ones that we would occasionally get pushback about is the lack of specific player details within the metric. Couple times, various past few years have come up where either a player is injured or there's roster movement in consideration, and people just question us why the metric says what it says when it comes to win probability or title chances. The new version of BPI is looking to accommodate some of those questions. A good example came in 2018. Cavaliers still have LeBron James. We're on that run where if LeBron's on your team, you've got a good chance of making the NBA Finals. With Kyrie Irving, Kevin Love, they still were a formidable force in the East, even though they were scuffling a little bit in that season. When Kyrie Irving went down with an injury in March of 2018, one of the first questions we got was why weren't the game predictions changing as well, given that Kyrie's now out? That's something where the older version of BPI doesn't account for that absence of Kyrie Irving to be able to update that. By the same token, and almost on the flip side of the same coin, when we came around to the playoffs, the Cavaliers had a pretty low percentage chance to win the title. Now, years of experience in the last decade have shown that if LeBron's on the team, you've still got a good chance of winning the title. So people kind of push back, well, why aren't you factoring for playoff LeBron? Why aren't you factoring for the fact that the Cavaliers are going to flip the proverbial switch? And again, the previous model of BPI didn't allow for any kind of juxtaposition of regular season versus playoff statistics. In the last couple of years, we've seen load management become an increasingly big deal across NBA. Guys like LeBron, Kawhi, if they sit, the Vegas spreads move significantly. And this is something where if Kawhi's out, depending on the opponent, it might move 3 or 4 points, maybe 5 points. But our BPI percent chance to win remains the same, again, for some of those same reasons. And it just becomes a more difficult story to tell. And you never want to have to tell a producer or editor, don't use something we produce right now for whatever reason. So that's, at times you had to because of the circumstances, but sometimes they're busy, and just getting them to fully understand the reason behind that can be a little complicated. And then with trades or free agent signings, generally anything that makes a roster significantly better or worse, there's that lag with previous model of BPI catching up to how good a team might be. Again, we saw that referencing LeBron James again, moving from Cleveland to LA, entering that first season with LA, the Lakers had, I believe BPI had a 2% chance to win the title. And again, that Lakers team wasn't great. It doesn't seem like it was far off, but Vegas had them at 18-1, which is fourth best odds of teams entering that particular season. There is that narrative among the public that if LeBron's on the team, they got a better chance to win. And it turned out, obviously, that first season, LeBron got injured. Lakers didn't make the playoffs and kind of vindicated there. But the previous version wasn't really able to attribute the fact that that LeBron made him better. And the same thing happened this past year with Anthony Davis, where entering the season, the Vegas bookmakers had essentially a three-way tie between the Clippers, Bucks, and Lakers as favorites to win the title this season. Obviously, right now, Lakers looking pretty good. BPI was a little slower to catch up until Anthony Davis and this Lakers team proved that they deserved it based on the performances on the court. So that's a lot of the different factors and examples that can show why we really needed to get a little bit more granular with BPI. Really needed to have more of that player focus to be more dynamic and be more flexible. And so this analytics team's done a lot of really great work to get us into that point, and I want to pass it back to Brian to talk through those details.
All right, great. Yeah, so we'll move into the more of the technical details now. We'll first talk about some player level performance data. And then we have estimated return dates for injuries, minutes projections, and those are kind of combined to create the player-based BPI, the player-based team strengths that power our game predictions, season projections, and our betting metrics that we'll talk about later. So the first metric that we'll talk about is real plus minus. So this is a player performance metric, uses play-by-play data, box score data, and advanced box score data that's derived from the player tracking data. It uses all those things in a regression model. It's a Bayesian hierarchical regression model. And the result of the model, the resulting coefficients, are estimates of the player's contribution to his team. And it's a measure that, since we're using a regression, we're able to account for the strength of the player's teammates and opponents in a reasonable way. So if someone plays with really good players, that's sort of taken into account here. Their performance might be better because they're playing with better players. So we're trying to isolate a player's contribution to his team using this regression model. And the resulting coefficients, which are the player metrics, are in terms of points per 100 possessions. And so real plus minus has existed for a while. The original creator, Jeremiah Engelman, who created it along with help from Steve Alardi. Jeremiah got hired by the Dallas Mavericks. I think it was last summer. The summer of 2019. The summers all are mushed together now that there's been COVID and we've all been home for several months. So he was hired by the Mavericks, so he couldn't do real plus minus publicly anymore. So the ESPN Sports Analytics team redesigned it over the past year, and some of the new features that the old version didn't have, we now have the advanced box stats that are used in it, as we mentioned before. It's a fully Bayesian model now, so the coefficients, we get full distributions for the coefficients, and then we went back a little bit further in time than before, so we now have it from 96, 97 to present, which is kind of cool because we can compare some late Jordan years with some of the later LeBron years, for example. But here is more recent RPM. So this is LeBron and Giannis over the past few years, sort of RPM trends over time here. And we kind of see Giannis taking over slightly above LeBron in the 1920 season. And so RPM is good as far as describing how a player has done in a particular season, and only uses data from one season at a time. For BPI, though, what we want is something that's a little bit more forward-looking. Maybe it doesn't describe, how good a player is this year, but we would rather have a metric that describes what we think a player is going to be doing in the future. And that's the aim of predictive real plus minus. And so this is a metric that uses a player's RPM trends in recent seasons, and also the player's age and sort of like average aging curves for a typical NBA player. So it uses those and creates a forecast of what a player's RPM will be going forward. And so you see a couple examples here. On the lower left, Luka, young guy, so he's sort of projected, he's right now 3.7 at predictive RPM, but sort of projected to increase over the next several years. And same thing with Zion on the right there. On the lower left, Giannis, he's in his mid-20s right now, so this has him staying fairly constant for the next couple of years, and then he's expected to begin tailing off a little bit towards his late 20s. And then LeBron in the lower right, predictive RPM expects him to sort of start decreasing from here on out, although, it might be underestimating LeBron since it's LeBron. He might be breaking the model. We'll see. Time will tell. And so here is just an example, just a visual that kind of shows that predictive RPM is a little bit smoother than RPM. It kind of smooths out some of those ups and downs. And that's because predictive RPM uses more than one season of data. And here's just the comparison of Giannis and LeBron again. Giannis sort of barely overtaking LeBron in terms of predictive RPM in this season. And so with that, we have one more. So we have it broken down between offense and defense, and this is just showing what the Lakers look like right now in terms of offense, defense, and total. And LeBron and Anthony Davis as the obvious 1 and 2 players, head and shoulders above the others. And so with that, we'll turn it over to Mitchell.
Hi, hello everyone. So RPM kind of gives us an estimate of the impact that each player has on their team's performance. The next piece we need is how often each player is going to be impacting their team's performance. So i.e. playing time. And one major limitation on playing time is injuries. And using injury data from RotoWire, we can predict when an injured player will return to action for their team. The RotoWire data comes with 3 different designations, one being game time decision, out for season, which we don't really need to make predictions about because they're just out. And then one kind of in between where a player is just considered out for some, arbitrary amount of time. So we've got kind of 2 different models for the 2 designations that we need to make predictions for. So the game time decision model, it's just a logistic regression where the predictors are, we've got a playoff regular season indicator, the age, the predictive RPM, and then the out with expected return date model. The predictors are the expected return date, which again comes from RotoWire, the age, and predictive RPM. And with that, in that model, we're trying to predict the days until return, and that model is a Bayesian negative binomial model. So for an example, Russell Westbrook had a quad injury kind of coming into the playoffs with an expected return date of August 20th. His actual return date was a little bit later because some of the games were suspended. And I think if we go to the next slide, we can see the estimates for how likely Westbrook was to return for each specific game. So there was a 51% chance that Westbrook would return for game 1 of that series. 49% chance he would return for game 2, and then some close to, but not 0 chance that he would return for any of the following games. So the next piece of the playing puzzle is getting some baseline chance to play, which is really just a player's chance to play given they're not injured. And that model is a logistic regression model where the predictors are game participation, participation history, age, and once again, the predictive RPM. And so to get the overall chance to play, we combine the baseline chance to play and then when players are injured, their expected return date. So Westbrook's chance to play in those 2 games that we were looking at before. So game 1, there's about 50% chance to play given his baseline of 98% chance. And then in game 2, to play in game 2, 98%, because it would have been the 51% plus the 49% from the game before. I think we have some visual, the projected minutes. So equally important is not just if a player is going to play, but how long they're going to play when they do play. So we've got another model that is not a logistic regression. It's a linear regression, but the predictors are minutes history, age, and predictive RPM. And then there's kind of a final step where we adjust each player's baseline minutes based on their teammates' baseline minutes for a game. So when a player like Westbrook is out for the game, that's going to increase the minutes that his teammates like James Harden or some of the other guys on the Rockets would play. So we also have kind of two different models for the baseline minutes projections, one for regular season and one for playoffs, because you kind of see in the playoffs better players getting more time. So some examples of that, regular season estimates for Giannis, about 38 minutes a game, LeBron, about 37 minutes a game, Dwight, Howard, 26, and somebody like Robin Lopez at about 7 minutes a game. And then you can see for the playoffs, those top guys get a big increase in their minutes. Giannis and LeBron about 10 minutes extra. Dwight's minutes kind of cut in half, and Robin's drop slightly. So then we can look at, we can kind of get an idea. This is the Rockets, kind of each of these numbers we talked about before. You can notice on Russell Westbrook's kind of line there, there's a lighter blue square in that game one. That's again the injury. That's an effect of the injury. And in the projected minutes column, it may be kind of hard to see. I don't know, but you can see James Harden's game one minutes are a little bit darker than his minutes for the rest of the series, and I believe you see a little bit with like PJ Tucker's as well. So, now we have kind of the pieces that we need to build our player-based BPI. So BPI is just a measure of team strength that represents how many points above or below average a team is. So now with this player-based, BPI is like a weighted combination of the players' predicted RPM and their projections of the top 8 players. Because minutes are distributed differently in the playoffs, like we said before, we have actually different BPIs for regular season and playoffs. And with that, I believe, turn over to Matt.
Hey guys, can you hear me?
Can.
Okay, so how's everyone doing? I'm going to talk. Okay, so we've talked a lot about all these sort of these models, and now we're going to talk a little bit about what some of these models produce beyond what Mitchell and others have already talked about. So one of the things we could do is predict game scores, so predict the score of games, and obviously to do that, the score of a particular team in a particular game is effectively their efficiency, their offensive efficiency and or defensive efficiency and points allowed, multiplied by the number of possessions in a game. So one of the things we do is we have a sort of a joint model to establish efficiency in possessions for both teams in a game. We have the game BPI for both teams in a particular game. As Mitchell talked about that, we also incorporate home court advantage, and we have travel information, and that includes days of rest, altitude, distance traveled, etc. Now, obviously, today's day and age, there's not much travel and there's not much home court advantage, but normally those things would be taken into account. So that's what goes into it, and we could estimate, assuming sort of day-to-day or load management, injuries and or not. So one example is projected scores for round 2, game 1, Toronto versus Boston, back in the earlier days of the bubble. Toronto won. If Toronto wins, we estimate Toronto to win. The mean estimate is 113, 110. If Lowry does play, and if Lowry doesn't play, it would be different. Next slide. All right, so here's sort of a distribution of the points scored and points allowed in the NBA Finals Game 5. Obviously, we know what happened. You can see it's a little skewed. It's not just like a clean spherical distribution. We estimated the Lakers to have to score slightly more points. These are sort of bucketed point ranges here. But effectively, we have we could produce visuals that kind of help us understand what the numbers are saying. And the Lakers ended up losing. And as a Laker fan, that was tough to see. We'll get them next game, hopefully. Next slide. All right, so Lakers' chance of scoring a number of points. Of course, we could. Here's a histogram to describe that. Well, actually, it says East first round game two, so I believe this is actually referring to the Toronto-Boston series. So ignore the fact that it says Lakers. But for the Raptors or the Celtics, one or the other, the chance of scoring in each of these ranges is as follows. So as you can see, most likely to score in the 115 to 120 range, given the efficiencies and the estimated number of possessions by both teams. Next slide. Point differential, same thing. So we were looking at points scored. Now we can look at point differential. Similar type of histogram. Next slide. Same thing with total score, and total score becomes important in a minute. Next slide. Okay, so but before we talk about total score, let's talk about chance to win. So obviously we have the projected score. We use that to establish a chance to win. ESPN talks about this all the time. And this is what goes into our eventual projections. Essentially, using projected scores, we could estimate a team's chance to win. So obviously, here's an example in that round 2 game 1 win with Kyle Lowry potentially being injured or not. 53% or 49% if he does not play, 58% if he does play. And so therefore the weighted average based on our chance to play would be 53%. Next slide. Now, here's where we talk about gambling. Obviously, ESPN is getting, and a lot of others are getting into more of this world. It's becoming legalized in a lot more states. So we're going to start, we've started producing content. Some of this more straightforward content is something like this, chance to cover the spread. Now in basketball, it's fairly easy. Scores are distributed fairly evenly. That's not the case in football. But here, the Lakers have a 62.5% chance to cover at -7.5, 60.9% chance to cover at -8.5. In other words, if they're favored by that amount of points, they have this amount of chance to cover the spread according to BPI. Obviously, one of the exercises here is to produce something a little more granular down the line and flexible such that as the point spread changes, we could establish chances and we could start calculating some more interesting factoids around betting. Next slide. Yep, and here's another graphic, chance of each points differential, and the line, and so we could kind of look at where the delineation occurs and the chance of falling on each side of a particular line. Next slide. And this is where we get back to the totals I was talking about. We also have chance to cover the over. So these are the two sort of basic gambling items. We were delving into other things, but one of them is chance for the total points to go over the total. With 212, we said 53% chance, 45 if it's under, 217, etc. So we could do we could slice and dice any number of ways. I believe we have one more visual here. Yep, the chance of each total score, and once again the sort of the line is indicated as the delineation there, and the chances of each going under or above is sort of the sum of all the individual percentages in the histogram there. So yeah, that's some of the stuff we could do. Next slide. I think that is it. And I think I'm going to turn it over to Lauren Poe.
Hi. Yes. Okay. So now that we have game predictions, we can derive season level information like estimated win totals, and that's helpful. We can compare that to Vegas win totals, and that provides some level of context. But what really helps is we simulate the season 20,000 times. And we can go to the next slide. And with the simulations, we now have a likelihood that each team reaches a specific win total. So this particular graphic was generated from a mid-season run, which is why we only have a few values here. But I think Vegas had the Celtics at 49.5 wins entering the season. So, but this provides a little extra context that we get from the simulations. Next slide. So within the simulations, we generate conference standings. And in order to generate those, we spend a lot of time writing tiebreak functions using the NBA conference tiebreak rules. Now we can seed playoff teams once we have the standings generated. And as a result, we have projected chance to make the postseason for each team. So these numbers were generated from a run in the bubble at some point where there were just a few teams that were still fighting for a playoff spot. Okay. And then within the sims, we schedule playoff matchups if they aren't already scheduled, and then we simulate each game within a series. And then we schedule the next round and so on and so forth. Eventually, each simulation has an NBA champion, and we can provide teams % chance to win the title. Things like most common playoff matchups. We can do draft projections after that. Because of the granularity of the data used for the game predictions, we can update simulations after injuries. So here we have the Celtics chance to win the title before and after Gordon Hayward's injury in Game 1 of the Eastern Conference first round. All of these examples are ways we can provide context and support ESPN's storytelling efforts, which is always the goal.
All right. Hi, everyone. So I'm going to talk about how we're going to use all of this information that we're generating. You have seen a lot of great charts so far, but the primary way that we use this internally is through apps and an internal website. So using these allows everybody within ESPN the ability to slice and dice this information to get what they need out of it. So everybody in this conference, everybody on my team, we might be able to handle an RDS file, open things up, slice and dice it however we want. But for a lot of these people, they aren't as technically inclined. So they can just go to a website or go to a Shiny app and just kind of use some drag and drop, click and point, that type of thing. It makes it a lot easier for them to get what they need to do their job. So that's where we have all sorts of things, our BPI ratings, our game predictions, season projections, draft projections, betting metrics, all of those things. Those all live on an internal website where each one of these researchers can pull this information out. Additionally, we also create apps for ourselves to make it easier on us to operate and run these metrics throughout the season. That's where there are certain things where it'll just be easier to have a drag down, drop down, and then that executes a function or a script or whatever, and that makes it a lot easier for us to use. So with that, I'm going to toss it to Hank, and he's going to talk about some specific apps.
Yeah, so when we started designing this, we almost started at the end and worked backwards, right? We had these things that we knew our content team would ask us, hey, what would happen if? And most of those kind of surrounded on injury scenarios and player team combinations. And what you see here quickly is just a quick screenshot of the kind of the beta app, the proof of concept really, that we could edit the injury info kind of right within a nice Shiny app. Change their status, the injury type, or the expected return date, kind of the status and the return date, the key values there, and run the metrics, at least a few hundred sims to kind of see what shakes out there. We could also do that if we go to the next slide, kind of the roster info. That's another thing. Hey, what if this trade does happen, or what if this free agent signs somewhere? Those are the two kind of key questions, at least we couldn't deal with at all in the older version of BPI that we now can in the new version of BPI, excuse me. And those kind of that's the baseline. That's the kind of the first iteration of stuff we want to do right out of the chute. And the content team is great at asking questions. I'm sure they're going to ask us some more great ones, and we'll continue to build that functionality out and kind of work forward and try to make this as robust a thing as possible. That was one of the things we really wanted to work on. In addition to that is just being more nimble. We don't want to have to sit around and wait for an overnight run or an external data partner to send us a whole bunch of information for us to react to breaking news. So now we can get this out to our content team and they could start writing about it, putting it on TV and all that other stuff. And I think Up next is Andre.
All right. So thus far, we've talked a lot about the models and the tools to create that we've created. And so I'll be talking about how, as a writer, the way that I use these tools to help inform the consumer. So my primary area of interest that I write about is the NBA. But you can see on this slide, I might write a fantasy basketball article, which has certain priorities, or sports gambling, or daily fantasy, or just NBA in general, or NBA analytics. These are all different articles that I might write that each will be using these tools in different ways. Next slide. So this is an example of a matchup that I was analyzing earlier this year for a Best Buy article. So that was focusing on a daily occurrence, a sports gambling occurrence for a particular game, the Timberwolves against the Hawks. It also had implications for daily fantasy. So at the time, we was using the old BPI model. We talked a lot about ways that we've improved it. Well, as you can see at the top, the Timberwolves were favored by 6 points over the Hawks. That was the spread. And so I had to decide which end of that argument to suggest that people lean on. Say that the Timberwolves can win by at least 6, or whether the Hawks can either lose by 6, less than 6 points, or win this game. And so using the old BPI at the time, it estimated that the Timberwolves would be favored to win by 6.6 points. So if you think back to kind of what Matt was showing a little while ago, you could kind of envision what the distribution might be. That, okay, well, if they're favored by 6.6, there might be a 52% chance that they cover this spread and 48% that they don't, or something like that. However, this was the old BPI, and as we've been discussing, there were things that could be upgraded and that now have since been upgraded. But at the time, I was the analyst, so I had to be able to be the supervisor of the model. Like, do I agree with what this model's telling me? And so this slide goes through some of the different elements that I might use as an analyst. One thing that caught my eye in particular when I was writing this article was this just appeared to be a very bad matchup for the Timberwolves, because the Hawks, even though they weren't a great team, they were excellent at running the pick and roll. They ran it more than any other team in the NBA, with Trae Young and John Collins as their main pick and roll duo. And the Timberwolves were terrible at defending it, with Karl Anthony Towns as one of the worst in the NBA at defending that play. And so that stuck in my mind real time with my predictions. Moving forward with our new BPI models, as was discussed earlier, BPI now factors in things like real plus minus. And so that real plus minus could tell us that Trae Young was actually second overall in the NBA in offensive real plus minus. He was, excellent at it. Karl Anthony Towns was almost last in the NBA in defensive real plus minus. So it would be able to help us realize that, this just might not be a good matchup for the Timberwolves. And coming back to our point, we might then want to favor that the Hawks are going to cover this spread. That was what I advised. It turned out the Hawks won that game 127 to 120. It was a really high score. So I talked about the spread. I also could have talked about the over-under. Both BPI, the new BPI, and me would have suggested to go over. And also for daily fantasy, we would have said that Trae Young and John Collins were really good buys. And Young went for 38 points and 11 assists. Collins went for 27 points and 2 3-pointers. And it was a predictable occurrence. So next slide. This is another example, not so much on a day-to-day basis like the previous, but more on a season-long, the way that Protos was describing earlier. You have an in-season trade. It was a multi-team trade, but for the Houston Rockets, they sent out, the main player that they sent out was Clint Capella, their all-star starting center, and the main player they brought back was Robert Covington, who didn't really have a big name. He was known as a role player. And the biggest, I guess, headline was that it meant that the Rockets started playing small ball. Their center was now 6'5", and it was just a different way of playing for anyone in the NBA. But real time, we want to be able to predict, what does this mean? Who won the trade? What, for NBA futures, how should that affect what we expect the outcome of the Rockets to be? And so when evaluating the trade, there's some things you might look at are fit. So the Rockets, their Daryl Morey basketball is very heavy analytics driven. He likes the high efficiency shots, which 3-pointers or driving to the rim. And he had a team where he had brought in Russell Westbrook as his big acquisition in the offseason, but he was still playing a true center in Capella. And neither one of them were proficient at shooting 3-pointers, which was bogging down their whole offense. And so just on fit, you might have said bringing in Covington for Capella might help the team offensively, might help Russell Westbrook offensively. If you're thinking in terms of fantasy basketball, it might help his numbers. But more broadly, it might help the team. Well, what you see about halfway down the bottom half of the slide, if you look at the offensive real plus minus numbers, it wasn't even just fit. Just over the last few years, Covington tended to be a more impactful, effective offensive player anyway than Capella. And his ability to shoot the three helped every team he was on, but would especially fit in with the Rockets. And so you might predict that Covington would be better than Capella offensively for the Rockets, regardless of the fit. And then the fact that the real plus minus captures that means that our models also, our BPI model will also capture that and maybe give the Rockets an offensive boost based on that. Now go to the next slide. We'll talk about the other side of the ball, and that's on defense. There's some pictures there that if you look at them from left to right, there's two different rows, and they're showing that I think Capella in his last full season with the Rockets, even though he was an all-star, he was a bit of a defensive liability, especially when he played high-powered teams like the Warriors, where these pictures were generated. It's hard to tell because they're relatively small pictures, but in the top one, I believe he got isolated on Klay Thompson on a switch. Klay was able to drive to the rim for the layup. In the bottom sequence, he was guarding Iguodala, but he was stuck, as you can see on the far left bottom corner, under the paint, where Iguodala is wide open out at the three-point line because Capella didn't have the flexibility to get out there. It resulted in an easy three-pointer. Well, those types of plays happened often enough that the argument was that Covington's flexibility as a perimeter player might fit in better with the Rockets' defense than what Capella was doing. But again, defensive RPM told us that just in general, Covington was a better defensive player than Capella and one of the best in the NBA. He was not, top 5 in a couple years, top 12 in the year before. And so that would argue that just impact-wise, Covington is better than Capella on defense and offense. And so you would expect then that the Rockets should have won this trade. So we could write articles that say, look out for the Rockets to get better. We could write articles that say, look out for Russell Westbrook to get better because the fit happened. And essentially that's what we were seeing, especially before we had to go into the bubble. I think Russell Westbrook was averaging 30 points on almost 60% field goal percentage. And the team was winning games. They upset the Lakers during that time period because they improved in ways that weren't readily obvious, but that our models would help us to be able to find. So next slide. I believe I'm passing it back to Protos at this point.
Yes, sir. And I want to leave a little bit of time for the questions. I just want to emphasize that a lot of what we do, we just had a very detailed explanation about revamping BPI. A lot of what we do for TV needs to be explained extraordinarily quickly. For live shows, if it's a studio show like Sports Center or NBA Countdown, you might get a little bit of time, like 30 seconds or 45 seconds to introduce and go through an entire segment using BPI or real plus minus. So the explanation has to be concise. And that's even a higher priority with the event broadcast where the focus is on the action. If you can't explain something in 8 seconds or less, it's going to be hard to get into the broadcast. So fine-tuning these metrics so that producers and talent trust them implicitly enough to say something like BPI says, or this person ranks this in real plus minus, and leaving it there is really a critical part of this. And behind the scenes, off the camera, we have a lot of those conversations to build that trust level. And what this analytics team does to help improve these metrics and provide those types of quick explanations is central to what we do on a daily basis. I believe I'll pass it back to Brian and kind of wrap things up and allow for questions here.
All right. Yeah, that's all we have. Here is our ESPN Stats and Information Group official Twitter account, and then the personal Twitters of many of the presenters here. Thanks again to the organizers for inviting us to speak. And that is all we got.
All right. Let's just clap to yourselves wherever you are for the presenters, for all the presenters. Yes. Brian, clap for yourself. I see there's a few questions in chat. I will just get right to these questions. Let's start off with, let's go in order. Shane Burton asked a question. Wait, let's start with this one. This is from Amir Bashar. Since you have a fully Bayesian model, what is the probability of Giannis and Luka Doncic to get near the RPM of the best players for several seasons?
I don't have the answer for what is the probability of that right now, but I mean, that's one of the nice things about having a Bayesian model is we can answer questions like that one. So yeah, I don't have that one memorized right now, but we could definitely look that up later and get back to you.
All right, thank you. How does he keep doing that? This is from Shane Burton. Do minute projections take injuries into account? Example: Jimmy Butler played 40+ minutes per game in the finals, while Adebayo and Dragic were on the injured list. Even with Bam back, Butler is still putting up 40+ minutes per game. So the question is: do minute projections take injuries into account?
So Mitchell, you want to answer that one?
They do. I mean, typically the injuries affect somebody's chance to play. The minutes projections are kind of part of the minutes projections is like recent playing history. So in kind of an indirect way, if somebody hasn't been playing recently, it'll, individual players down. But I think to answer the question about Butler's minute relative to his teammates, yes, like we would be able to see that two of Butler's teammates are coming back from injury, and if there are guys that are getting a fair amount of minutes, that we might see Butler's minutes go down by a few.
Okay, thank you. Here I've got a heated question here. The question is the real plus. This is from David Fenichel. The real plus minus for 2018-2019 shows JJ Redick at 26, JJ Barea at 30, and Kawhi at 46. Why is this happening? And then he says, given that these results do not seem to pass the laugh test, how can any of the results be meaningful?
If it makes you laugh, does that mean it passes the laugh test or fails? I forget how that goes, but I mean, a couple of things. Like, I guess maybe the main comment is Kawhi is 46 or 48 or whatever it's said. Should mention that the RPM on the website is regular season only. And Kawhi is one of the weird players where there's a couple years where he's not as high as it seems like he should be. There could be a couple reasons for that. I haven't looked into the 2018-19 season for Kawhi in a while, so I don't have any good details on why his RPM is very low. I'm pretty sure this year he ended up in the top 5, but I think a big part of that is, Kawhi steps up his game in the playoffs, and the RPM on the website is regular season only. And we also have a playoff only RPM that we've been developing, and also one that combines regular season and playoffs. So he would most likely be higher in those, I would guess, although I don't remember what his numbers are in 18-19 season.
Can I add a little bit too?
Yes.
One thing to keep in mind with especially the RPM, the any plus minus based stat, is that it's an actual stat. Like we're doing regressions to try to improve the the precision or to try to make it like the cleanest calculation possible. But at heart, it's looking at how much does the scoring margin change? How much of a scoring margin change can we regress to a single person? So if JJ Redick has a really high score, this should not be used to say, well, his RPM says he's 20, so he's better than Kawhi Leonard, who's 40. It's not a better than stat. It's saying that we can trace the scoring margin of JJ Redick's team. It increased by this amount when he was on the court versus when Kawhi was on the court. So it's not a case of laughability. It's not a case of, well, this doesn't say what I expect. It's more, this is what happened. To the extent that we can calculate it, this is what happened. So then it becomes up to the analyst to figure out, well, why did this occur? So Brian was pointing out that for Kawhi, some of the whys are that in the regular season, he tends to load manage more than any other player in the NBA. He'll either miss games or he might play fewer minutes. And he could also, you could postulate, be modulating his intensity. So maybe that's why he's a little lower than you would expect. Why might Redick be higher? Well, he's a three-point shooter. He spreads the court. And he also, I believe, comes off the bench now. Maybe when he comes into the game, the team is set up such that they take advantage of his spacing and it helps their scoring margin. But whatever the case, this shouldn't be taken as we're saying JJ Redick is better and the numbers prove it. We're saying that this actually happened. The team improved by this amount while he was on the court, and it's up to you to figure out why.
And like we described, predictive RPM smooths things out and would undoubtedly change things for Kawhi in last year. But just to be clear, Kawhi Leonard was 7th this year in RPM. So I think we would have predicted he would have been pretty impactful, although not impactful enough this year.
Okay. All right. Thank you for that answer. I'm sorry I asked such a combative question, but you all work at ESPN, so I assume that 90% of your job is just reading comments where people are like complaining about the work that you've done. That seems like what's probably happening over there, or at least on Twitter. They're like, this metric's terrible. Anyway, so this is a question from June Yan. What is the you talked about a logistic regression model to predict minutes played, and June is asking, what is the outcome variable in the logistic model to predict the minutes played?
Yeah, that was a typo. It was not it was a linear regression, and it was just the outcome was the minutes played for a player's game. I mean, each observation is a player game. So then the outcome was the number of minutes each player played.
Okay, yeah, that makes more sense. I was wondering that too. All right, so it was just a typo. Okay. Here's a question from Krishna Sankaranarayanan. Other than articles, what does ESPN use the analytics? What? Let me start that again. Other than articles, where else does ESPN use the analytics results?
I'd say we often use it on SportsCenter. It's something that's part of the storytelling to help set up games. Transitioning from one discussion to another on TV, it's a very easy thing to talk about the expectations for the game. And when you're talking expectations, you can lean on analytics, you can lean on Vegas numbers. That's a good way to kind of get in and out about kind of what's predicted to happen here. Certainly with title odds, when there's a surprising result, people are very interested in knowing how those have changed over the course of maybe a month or something like that, depending on how teams do. A team like my favorite team's the Falcons in the NFL. we use our NFL metrics to talk about how much any chance to win that division's gone from slim to absolute zero now. So it's a big part of the conversation across platforms. It's just being able to tailor that to the audience and the time you have to discuss it.
Yeah, and as Protos mentioned earlier, the announcers are starting to incorporate it more into their game analysis. Like I think about Doris Burke in particular. She always finds a way. I think at the start of one of the games, maybe 5 seconds in, she was talking about how Rudy Gobert was top 5 in the NBA in defensive real plus minus, to really give his credentials in a different way from just saying former defensive player of the year. She can say, well, he was number 3 in defensive RPM this year, and get her point across in 8 seconds or less.
Oh, also, it has like an indirect use for us as well. So like behind the scenes when we're deciding, like when we're trying to make decisions on what to cover, or to choose between this team or that team for a subject or a topic on a show or a podcast or whatever, that these analytics can help fuel the decision making versus just going off of basic stats and whatnot. So that's where it helps us look a little bit longer term in some scenarios and help us plan ahead in ways that we couldn't otherwise.
That point from Neil reminds me that we also work with our programming department to look ahead at schedules. Whenever there's any flexibility to move games around, we can kind of predict which games might mean the most for a playoff race or along those lines.
Yeah, a good example of that was for the play-in tournament with the NBA. We were doing daily updates on percent chance of there being a Western Conference play-in tournament and a percent chance for all of the specific matchups, and then the same thing for the Eastern Conference. So that really helps them do their jobs in a much more informed manner.
All right, thank you. Next up, I'm just rapid firing at you. This is from Christian Panici. Is this methodology also applied to NCAA basketball? Like, have you done anything with this, with college, with this, to help inform things like mock drafts?
So we have not done any sort of like real plus minus for college players. So we don't have a player-based college BPI. As far as mock drafts, we do have a newly updated NBA draft projections, and that involves using college data and other information to predict a player's predictive RPM in his 4th year in the NBA. So that could help you with preparing for a draft if you're a team, or if you're trying to talk about what might happen in the draft. It could be if you're at ESPN, that kind of thing could help with that too.
Okay, thank you. I think you addressed this a little bit, but I'm going to read the question anyway. It says, "Thank you all." This is from Will Riley, so this is not a heated question. "Do you consider RPM to be fully indicative of a player's value? How do you account for the other variables that may affect a given player's RPM? And is there evidence of changes in the plus minor of players when a particular teammate who elevates the team is on the court? How might team is a long question. How might team chemistry be measured to explain when a team under or overperforms compared to the expectation based on the sum of its parts?" So I guess let's just start with the first question. Do you consider RPM to be fully indicative of a player's value?
It is an estimate of their overall value. I would not consider it to be fully indicative of a player's value. I don't think any of these player metrics I don't think you can claim any of them are fully indicative of a player's value. As far as, I don't remember all the questions that you asked, but as far as some of the other ones, it does not currently take into account any sort of team chemistry in the model. So that's not considered in the model. There's no interaction terms or anything like that in the model, and no other way that we're trying to take into account team chemistry in that particular model. I believe that has recently become a component of the BPI model, though, but I would have to check with Paul on that, and Paul isn't here. But I think he recently incorporated a team level variable, which would it's a team level variable, and as part of that, it would be picking up some team chemistry type effects if those in fact do exist for that team. What were the other questions?
That was a long one. We'll just I think we only have time for one question left anyway. I believe this is supposed to end at 4:15. It's 4:15 right now. I have one last question for you. I think this is an interesting one. This is from Dipesh Patel. Has BPI beat the Vegas odds if you take out the VIG? So have you ever tested this against like sports books? Basically, are you making a ton of money on the side betting on sports?
We have not compared this with the new version of BPI, but someone might be able to talk about the old BPI.
Yeah, so I can talk about that a little bit. For all of our models, we do submit them to a website called the Prediction Tracker, which does track model performance against Vegas. It's fairly basic at this point, and it for us it's just kind of a good litmus test for where we're at versus what else is out there. We generally always perform pretty well. But I guess one thing I will note that was interesting is we recently redid the college BPI, I want to say 1 or 2 years ago. And we didn't start publicizing the numbers until about January of that season. And then once we started publishing the numbers, we noticed that its performance over Vegas dramatically dropped. So that's where, since our numbers are public facing, you can get them on ESPN.com. A lot of people go to ESPN.com. It seems like the second that ours kind of are very publicly available, whatever edge our models do have go away somewhat quickly. So hopefully that kind of gives you a good answer around it.
One thing I would add on the sports betting topic front is that what the lines that bookmakers produce and the numbers derived from analytics can often do different things. So sportsbook has a market element to it where large bets on one side can move a spread one direction or can move the money line price in a direction. Sports books are motivated to manage their liability, and especially within the greater ecosystem of other sports books. So the closing line might not be indicative of what the odds makers think that the real percentage chance to win would be or the real spread is, nor is the opening necessarily indicative of that either. It kind of depends on which sports books have expertise in a particular topic, like the NBA. It's not uniform across all sports books.
All right, I think that's it. I think we're done. Let's thank all 450 ESPN employees for coming to the UConn Sports Analytics Symposium. This was a great talk. I'm sure you inspired many young people out there to move forward in careers in sports analytics and take more math and statistics courses. You're all true heroes.